Hello everyone, thanks for tuning in. This is Kisembo Academy. In today's video, I am going to go over some numbers on pressure. This is a collection of IGCSE physics numbers on just pressure. And this is the very first video of the kind that I am doing on the channel. So let's get right into it. Question 1. Which situation is an example of a force acting over a large area to produce a small pressure? Now here they're talking about pressure in solids. Now here is what we know about pressure in solids. Pressure in solids, the smaller the surface area of contact, the higher the pressure. For example, if I pierce a needle into your skin like that, this sharp point as I pierce this needle into your skin will pain because the area of contact between the needle and your skin is small, and as such it exerts a very high pressure. However, if I used the other side of the pen and I tried to pierce using this blank end, I won't feel any pain because the surface area of contact here between this part and my skin right here is big, and so the pressure will be low as a result of that increased surface area. So when we compare this to that, the situation is an example of a force acting over a large area to produce a small pressure. So if you are to compare this to that illustration to this, which situation is an example of a force acting over a large area to produce a small pressure? So we have a builder hammering a nail into a piece of wood. No. Why? Because we are looking at a nail, a small surface area entering into a piece of wood, that is high pressure. A cook using a sharp knife to cut vegetables, the knife edge is sharp, so surface area of contact between the knife and the vegetables is small, and because of small surface area, high pressure. But C, a nurse pushing a needle into a patient's arm, that's the same as A. D, a soldier marching in flat-soled boots. Of course, the answer is D. When a soldier is marching on flat-soled boots, that's an example of a force acting over a large area to produce a small pressure. That's question number 1. Let's go on to question number 2. A student places 4 identical beakers on a bench, 2 beakers containing salty water of that density, 1.1 grams per centimeters cubed, and 2 beakers contain pure water of density 1 grams per centimeters cubed. Which beaker exerts the greatest pressure on the bench? First of all, let's look at, we have salty water right here. We have salt water, then we have here pure water. And it so happens to be that we have salty water that is 150 centimeters cubed and 100. 150 centimeters cubed salty water and 150 centimeters cubed pure water. Then we also have 100 centimeters cubed of salty water and 100 centimeters cubed of pure water. So let's first distinguish between the two, pure water and salty water. Which of the two exerts higher pressure than the other? Remember, pressure by definition is the force acting normally per unit area. So it means the force is the same as weight. So between pure water and salty water, which of the two is weighty? Which one gives a bigger force? Of course, since here we are looking for they're asking us to find which beaker exerts the greatest pressure on the bench. Salty water has a higher density because on top of the water it has some impurities in it, which is salt, and so the density of salty water is higher than that of pure water. It means that salty water is more likely to produce a greater pressure because of its high weight or its greater force exerted. So it means that pure water is kicked out automatically. So we will look at these two options, A and B. Salt water here is 150 centimeters cubed. Here it is 100 centimeters cubed of salt water. Of course, of the two, which one is going to exert higher pressure? Of course, this one, because it is more. But let's not forget that when we are talking about pressure in liquids, pressure in liquids increases with depth. In other words, the deeper the water, the higher the pressure. And if we are to compare these two liquids, this one is deeper compared to this one, so our answer is going to be A. Question 3, the diagram shows a simple mercury barometer that is right there. Atmospheric pressure decreases. What happens to the level of mercury at P? And what happens to the level of mercury at Q? So when atmospheric pressure decreases, remember atmospheric pressure is acting outside here. This is atmospheric pressure. There is a force pushing down here, and there is a force pushing down here as well inside the tube right there. So it means that if atmospheric pressure decreases, it means that the force pushing this liquid down from here is going to relax a bit. So if it relaxes, it means that at level at Q, the water level here is going to raise up a bit, and so it means that the one at P is going to drop down. So here our answer is going to be B. B, saying that the level at P is going to fall and the level at Q is going to rise. Our answer is B. Looking at question number 4, the diagram shows 3 different containers, J, K, and L. Each container contains water of the same depth. Which statement about pressure of the water on the base of each container is correct? A, the water pressure is greatest in container J. No. For starters, even before we go into the objectives, it's a property of pressure in liquids, that pressure in liquids increases with depth. And also that is one of the properties of pressure in liquids. Then the other property, liquids that are at the same height will experience the same amount of pressure. So in other words, the water pressure is greatest in container J. There is no such thing as pressure being greater in any of these containers. Why? Because they are all at the same level. So A is out. The water pressure is greatest in container K. No. The water pressure is greatest in container L. No. The answer is D, which says that the water pressure is the same for all the 3 containers. So our answer is D. The other properties of liquid pressure are pressure increases with depth. Then also pressure at a point in the liquid is the same in all directions. Next, a water manometer is connected to a gas supply. There is a gas leak and the pressure of the gas supply falls. So if there is a gas leak, the pressure of the gas supply falls. If the pressure of the gas supply falls, it means the amount of force that is causing this thing to move down is going to relax a bit. And what happens is that this P will rise up a bit and that Q will slope down a bit. That is the consequence of this gas leaking. The force that has been coming will reduce and this water level will rise up. So the question says there is a gas leak and the pressure of the gas supply falls. So when it falls, they're asking, what happens to the water level at P and what happens to the water level at Q? I think I've already mentioned that. P is going to rise and Q is going to fall. So that is C. The scale diagram shows 3 identical blocks, P, Q, and R. The blocks have different areas of contact with the ground, as you can see. So we have blocks P, Q, and R, and the question says that they have different areas of contact with the ground. However, they are identical blocks. So because they are identical blocks, it means that their weight or the force they are exerting is the same. However, their surface area of contact with the ground is different. And now the question, which block exerts the greatest pressure on the ground? Now, in solids, pressure in solids, the smaller the surface area of contact, the higher the pressure. And if you look at these 3 faces, P has the smallest surface area of contact with the surface. So it means that P exerts the greatest pressure. And in this case, our answer is A. A manometer is used to measure the pressure of the air in the container. Which change would give a bigger value of height H? So this is the height. And remember we said that pressure in liquids increases with depth. So it means that this height is representing the pressure of that column. because as far as pressure in liquid is concerned, we are it's about the height. The longer the height, the higher the pressure. So they're saying that which change would give a bigger value of H? A is using a less dense liquid, B is using a more dense liquid, then C using a narrower tube, and D using a wider tube. Now, first of all, for C and D, these ones are out. Why? Because as far as pressure in liquids is concerned, whether the tube is narrow or wide, as long as it's the same level, the pressure will be the same. In just our previous question here, we looked at this question, and as you can see, the diameter of these tubes is not the same. You might find that this is wide, this one is different shapes. Maybe there could be another one here that is narrower than all these three, but still the water level will always be the same, as in the pressure is dependent on the water level, and it will be the same regardless of the shape. So relating that to this question, if we are to adjust the diameter of this tube to make it either narrow or big, that it would not have any bearing on the pressure of the liquid, or in other words, the height of the liquid. It will still remain the same. The answer lies in the density. Now the question is, do we increase the density or do we reduce the density? Do we use, if the density of this liquid is 2, if we used a density that is lower than 2, it would surely increase the height. And so meaning our answer here is using a less dense liquid, our answer is A. A drawing pin, that is a thumbtack, has a sharp point and a flat end. So this is the drawing pin. The pin is pushed into a wooden board. So we push this pin into a wooden board. How do the pressure and the force at the sharp point compare with the pressure and the force at the flat end? So we have the sharp point right there and the flat end right there. They want us to find the pressure and the force at both the sharp point and the end. For starters, when I impose a force here, if I put a force here, the same amount of force is what is going to be experienced at the sharp end. So as far as the force is concerned, the force is always going to be the same. This is the same concept even when we deal with Pascal's principle of pressure. Pressure in an enclosed fluid, when a liquid is enclosed, pressure exerted at one end of the piston will be equally transmitted throughout the whole liquid, regardless of the surface areas at both ends of the liquid. So it's the same thing here. If I put a thumb here, the force experienced at the flat end will be the same force experienced at the sharp end. However, the pressure experienced won't be the same. The pressure experienced at the flat end will be less. The pressure experienced at the sharp end will be high. Again, this borrows from the concept that pressure in solids is such that the smaller the surface area of contact, the higher the pressure, because the force per unit area acting on a sharp end is higher, so it makes the pressure higher. So answering this question, looking through our objectives, our answer is C. Force at the point is going to be the same at the force at the flat end. However, pressure at the sharp point, because the sharp point is a smaller surface area, so the pressure will be greater than at the flat end. Our answer is C. So the diagram shows 4 divers at the bottom of 4 different swimming pools. 2 swimming pools contain fresh water and 2 contain salty water. Fresh water is less dense than salty water. Which diver feels the least pressure from the water? So we have salty water and we have fresh water. First of all, we are looking for least pressure. So when you're looking for least pressure, remember pressure in liquids increases with depth. So it means the 2 swimming pools that are very long, that are deep, are out, because these ones, the depth is very high. So we go in for the ones that have a shorter depth. So it's between this one and that, B and A and C. So between A and C, which one experiences the least pressure? Now between A and C, we have fresh water here and we have salty water here. Now we know that salty water is heavier because of those impurities. The water in the salty water has a higher density, and because it has a higher density, therefore it imposes a higher force per unit area. And so it means that as far as this is concerned, the water that is on top of this man in the salty water is going to be heavier than the water above him in fresh water. And so it means that A will impose the least pressure of all the four options. It is dangerous for submarines to dive into very great depths. Why is it so dangerous? Remember, we said that pressure in liquids increases with depth. When we're dealing with submarines, there is such a thing called, when the engineers are designing submarines, there is a depth we call the maximum depth they can go. It means that as these submarines go down there, they are experiencing a certain weight of water on top of them, a certain pressure. The deeper the marines go, the higher the pressure they experience on the submarine. So if this submarine goes so deep, it means that it is subjecting itself to very high pressure, and if the pressure is too high, it can easily crash the submarine down under the water, and that would mean that the people in the submarine could die. So why is it dangerous? Of course, it's dangerous because it could crash the submarine because of the very high pressure it would be experiencing when it's underwater. So from our reasons here, why is it dangerous? A, the density of water is less at greater depths. No, the density of water is the same throughout, whether the water is on the surface or below. B, the pressure of water is greatest at greater depths. Yes, the answer is B. It's because the pressure of the water is greater at those depths that it's dangerous for submarines to go so deep. Of course, when you come to C and D, the temperature of water is higher at greater depths. No, the weight of the submarine is greater at greater depths. The weight of the submarine is the same whether it's on top or below. So this is not a reason why they should not go down. The reason is B. We have another question there. Which block exerts the greatest pressure on the surface below it? Again, these are solids. The block that exerts the greatest pressure is the block with the smallest surface area of contact. So let's first establish that. We eliminate stuff here. So we have, of course, naturally, blocks that are heavier are expected to exert a higher pressure. Of course, first of all, as far as pressure in solids goes, solids, smaller surface area of contact means higher pressure. Now, if you look at these four, we are going to eliminate this one and that one because the surface area of contact is large. So we are going to look at this one and that one. These two, their surface area of contact is low. We are looking at which block exerts the greatest pressure. So this one, the surface area of contact is low. This one, the surface area of contact is low. However, let's look at the forces exerted per unit area. Since the area is the same, here the force or the weight is 100 newtons. Here the force, or call it the weight, is 200 newtons. So this one is heavier. And because it's heavier, it means it is exerting a weight, or it's exerting a force per unit area, which is higher compared to this one. And of course, by definition, pressure is force per unit area. So C exerts the greatest pressure on the surface below it. Our answer there is C. Right here, which statement is explained by reference to pressure? A, objects with greater mass have greater weight. Yes, but this is not in reference to pressure. 1 kilogram of water occupies more volume than 1 kilogram of lead. There is no pressure concept there. Spikes on a running shoe sink into the ground. Yes, answer is C. Then water cooled by low enough temperature turns to ice. This is something thermodynamics. So which statement is explained by reference to pressure? It is C. And it's the reference here is the issue of surface area of contact being small. Because of it being small, being responsible for high pressure, and it is because of that high pressure that the spikes on the running shoes sink to the ground. The diagram shows two mercury barometers. Barometer 1, this is right here, is measuring atmospheric pressure of day 1. Then this one is measuring atmospheric pressure of day 2. Which statement is true? Statement A. The atmospheric pressure on day 1 is less than the atmospheric pressure on day 2. Let's look at the pressure. How do we tell the pressure in barometer 1 and 2? We are going to look at the length of the mercury column. If you look at the length of this mercury column, it comes from there up to right there. The length of this mercury column is from there up to right there. When you examine these two lengths of the mercury column, you realize that the length of this mercury column right here is longer than this one. So if the length of this mercury column is longer, it means that the pressure here is higher than here. Why? Because pressure in liquids increases with depth, or it depends on depth. So here, this pressure here is high. Yes, you might get confused. Yes, here they are at the same level, true. But when you go to where they are starting, they're not starting at the same point. If you're to look closely, looking at this thing closely, the pressure here, the surface of this liquid is here. The surface of this liquid is a bit raised. So it means that the pressure from top to bottom, this height here is taller or is longer than this one. So the pressure here is higher. So it means that this part A, when they say that the atmospheric pressure on day 1 is less than the pressure on day 2, that is not correct. Then part B, the atmospheric pressure on day 1 is the same as the atmospheric pressure on day 2. That is also still not correct because this length is longer than this one, so the pressure here is higher. Let's go to C. C says the pressure at point X is less than the pressure at point Y. Let's look at point X. If you look at point X and point Y, these are 2 points beneath, down in this dish. However, when you look at their level here, where they are on the same level. And when you look at them being at the same level, the amount of mercury on top of them, on top of X, and the amount of mercury here on top of Y is the same. How do you know? They are starting at the same level here, and the height upwards is the same up to there. So it means that the pressure experienced by this point X is the same as this pressure experienced at the point Y, because the height of the mercury above them is the same. Do not confuse this with the height I was talking about earlier. The height I was talking about earlier, the kind of height that shows the atmospheric pressure in these two barometers, is measured from the surface of the mercury in the dish. And you see that the surface of this mercury here is lower than the surface here. So it means that the height of mercury column above the surface here is longer than the height of mercury column above this surface. So that makes this the pressure on day 1 for here to have been higher. However, when you look at these points they are talking about, they are at the very bottom, and according to our question, they are on the same level. And because they are on the same level here, and the level on top there is also the same, it means that the height of mercury column above that point and the height of mercury column above that point is the same. So it means that the pressure experienced at point X and at point Y is the same. So it makes option C wrong when they say that the pressure at point X is less than that at point Y. No. However, D says the pressure at point X is the same as the pressure at point Y. So D is our answer. So a brick with flat rectangular side rests on a table. here and right there. A brick is now turned so that it rests on the table with its smallest face. How has this affected the force and pressure exerted by the brick? Of course, this is what we've been doing. I've over-explained this. So what has happened to the force? The weight of the block is the same. You're using the same block, it has just been tilted. So it means the force has been changed. So it's either C or D. The force has been unchanged. And then they're saying, how has this affected the force? The force has been unchanged then, and the pressure exerted by the brick on the table. Of course, here the pressure is low. When you turn it like this, small area of contact between the brick and the surface of the table, it means the pressure has increased. So it means our answer right there is C. A water manometer is used to measure the pressure of a gas supply. When it is attached to a gas supply, the water falls to the left side and rises to the right side. In other words, when we push a gas here, it's going to push this water supply down and this goes up. Okay. The difference in the levels of water on the two sides is now 20 meters. Yes. So what is the pressure of the gas supply? Looking at this gas supply more closely, when this water level drops and this one raises, it means that this thing is going to look a bit more like this. It means you're going to have something like this. When this one rises, it comes like that. This one drops to there and the gas supply is there. So it means that up here, like the way you're seeing here, this is 10 down and 10 up. So this is 20 centimeters. So to find the pressure of this gas supply, the pressure of this gas supply is the pressure, we shall take that level. And we shall say that the pressure at point X is the same as the pressure at point Y. The pressure exerted by this gas at point X is going to be the same as the pressure exerted at point Y. And what's the pressure exerted at point Y? The pressure exerted at point Y includes the pressure of that mercury column plus the atmospheric pressure here. So it means here, to get the pressure at point Y, which happens to be the pressure exerted by this gas, is going to be equal to the pressure due to that 20 centimeter column plus the atmospheric pressure. And so here our answer is going to be D, the pressure due to the 20 centimeter depth of water plus the atmospheric pressure. This will be our final question. A chair is placed on protective caps to prevent damage to the carpet underneath it. How do the caps change the area of contact with the carpet and the pressure on it? This is also a concept that we've been talking about over and over again. So how do the caps change the area of contact? These caps, they change the area of contact in a manner that they increase it, so it's either C and D. Then, how does the caps change the area of contact with the carpet and the pressure on it? So first of all, the area of contact is going to increase it, so it's either C or D. So when it increases, of course, the pressure is decreased. Answer is C. This video has been the very first of a kind where I am doing past paper question on IGCSE for physics. Let me know if you want to see more of these kinds of videos. If there is any improvement in the way this video has been presented, please let me know. You realize that on my channel I have been presenting my videos using markers. For the first time I am only using a pen. If you give me any feedback regarding how this video turns out, that kind of feedback is much appreciated. It helps me know how to serve you best. Again, I repeat this topic. I have recorded a full lecture on pressure from the very basics of pressure till the end. If there are any topical based past paper questions that you'd like me to cover, or a topic you feel I should cover with focus on past paper questions, please let me know in the comments below. Like this video if you like it. If you've not yet subscribed, consider subscribing. Check out other awesome academic video tutorials on this channel, and as always guys, thanks you very much for watching. My name is Arnold Rangakuramia and I'll see you next time. Take care.